Hey guys, okay, so what I'm going to do in this video is just explain a little bit of the behind the scene processes of data analysis. And in order to do that, you need to understand some basic elements around statistics. So, since we're dealing with water polo players form a very specific part or component of the population as a whole, right? If you think about the population of South Africa, there's probably a subset of that, small subset of that, that are actually water polo players. But for our specific study, since we're interested in only water polo players, all the South African water polo players would form part of the water polo playing population. Alright, so that's in essence what you see over here on screen is, let's say for example, that all these dots, whether they're green or orange, are all the water polo players in South Africa. Now, since we're interested in testing them, we obviously can't get access to all of them in South Africa because the cost implications for that would be huge, right? We'd have to travel to each province, to each water polo playing club, and then try and assess every single one of them. So often what we do is we'll take a sample or a subset of the population and test them. So since we're based in PE, it's probably going to be easiest to test the water polo players in Port Elizabeth, right? Um, the other thing that we're interested in is to see if there's any differences between playing experience. So are there differences in your playing ability in terms of how fast you shoot, how accurate you shoot, how high you come out of the water, how much shoulder rotation you have, so on and so forth, between novice and experienced players. And that's in essence what you're seeing on screen here is that, for example, let's say the orange dots are all your novice players and the green dots are all your experienced players. So if we were to take a sample, so I'm just going to take any random, say 9 or 10 players. I'm going to assess and analyze them. I'm going to group them into their levels of experience. So here are the 5 inexperienced players or novice players, and here are the 7 experienced players. I just, those are the only ones I had access to for the study, for example. And I measured their throwing speed, and I found that the average throwing speed of the people that I sampled was 8.5, and the amount of variation between their throwing speeds was about 1.2 meters per second. And you'll see here that in the sample, the experienced players had a higher throwing speed, and they also had some variation. Obviously, not everyone threw exactly the same. They had some variation on average of about 1.3 meters per second. Okay, but that's only obviously true for this sample, and you can see there's a whole lot of players that I haven't gotten to yet. So let's say these players happen to live in Port Elizabeth. If I had to take a separate sample still of Port Elizabeth playing or Port Elizabeth based water polo playing players, yeah, real tongue twister, I might get different results, right? I might sample completely different people, and there'll be different combinations of experienced versus inexperienced players. So if I shift that, you can see now I've got a lot more inexperienced players and only a few experienced players that I sampled. And again, if I measure them and I get a mean of 9.1 meters per second in this case, which is slightly higher than the previous sample, and their standard deviation has gone down. They were more closely grouped together. And you'll see here that in the experienced group, um, they were slightly slower, right? And their standard deviation was fairly similar. I think they had 1.2 or 1.3 in the previous sample, right? And I can go on and on and on and on, testing almost an infinite number of combinations of players, right? It just depends on what I have access to and how long I can make the study last for, and how many players volunteer. And you'll see that if I have enough of these samples, I can start getting a fairly good idea of what the average shooting speed is of water polo players, whether they are inexperienced or experienced. And hopefully, by me taking a large enough sample, I can generalize those findings to the entire water polo playing population, right? But again, there's some degree of uncertainty in all of that, and that's why generally we try and get our samples as large as possible, because that's going to be more representative of the whole population, those people that I couldn't get to, right? So the key finding in all of this is that you can see here these combinations, these samples from the population vary, and if I take enough of these samples, over time we get what's called this normal distribution curve, right? That a whole bunch, if again I'm making the assumption that this is the inexperienced guys and these are the experienced guys, um, out of all of these samples, you'll find that even out of all of these samples, if I average their values, most of their values will be around a certain speed, where the speed over here is on the x-axis and the number of observances or observations are here on the y-axis. So you can see here that the greatest average is around about 7.8 to 8.4 meters per second, and I had the most number of samples fall within that category. And you'll see there's also some range between 8.47 and 9.13, and then as I get to the more extreme ranges, those numbers tend to drop. So yes, out of all of the samples that I took, maybe there were a couple where the inexperienced players actually had quite high speeds, but there was only a very, very small subset. Same thing on the opposite end of the extreme. There were some that were incredibly slow, right? 5.83 to 6.49, but there's only a few of them. But most of them tend to accumulate here in the middle. The same thing's true for the experienced guys. You'll see here that the greatest number of all of the samples that were taken kind of fall here between 10.57 and 11.29, right? There were quite a lot of observations of that. Again, there were some that had really, really high throwing speeds, 11.73 to 13.45, but there's only a few number of observations that fall within that category. So maybe these are outliers, right? Same thing with the really slow ones in the experienced group. Some were 7.69 to 8.41, but again, it just made up a small number. Most of them tend to aggregate here in the middle. Okay, so once I've got that kind of information, I want to see if the average of all inexperienced players is significantly different from the average of all the experienced players. And to do that, we run some statistics, some statistical procedures in order to get to that kind of an answer. And I'm going to keep it basic because there's a lot of underlying assumptions that we're not getting into. But again, this is just basically an introduction to what you guys will be doing. All right. So let's say for your specific analysis, these are all the novice shots, right? And these are all the expert shots. Now I want to find out what the average is, the standard deviation, what were the minimum and the maximum values within that. So in Excel, what I'm going to do is press the equals button. I'm going to press average or enter average, and then open bracket. And I'll just highlight all of these numbers, then close bracket and press enter. It's going to take me one cell down. Now I want to find the standard deviation. I'm going to press equals, type in STDEV. So that's going to give me the standard deviation. Dot P is for the population and dot S is for the sample. So I'm going to use the dot S one, open brackets, and then again just highlight the same set of values. Close brackets, press enter. Now I want to find the minimum one. I'm going to say is equal to, and then enter min, open brackets, highlight the same values, close bracket, press enter, and then same for maximum. I'm going to say equals max, open bracket, and then highlight the same values. So within this particular set of shots, you can see the average speed was 8.51 or 8.52 meters per second. The standard deviation, the amount of variation there was within that, is plus minus 1.51 meters per second. Most of the shots were well within that. There were a few that were slower than that and a few that were faster than that. The slowest one was about 5.9 and the fastest one was about 10.6. Okay, I don't have to retype all of that if I've created my columns this way. All I have to do is highlight this and then take my mouse to the bottom right hand edge until the cursor changes to that dark plus sign, and I just drag it across, and it's automatically going to recalculate those values for this particular column. So what you'll see now is that the average for the expert was 10.92, the standard deviation there was 1.39, the slowest shot there is 9.1, and the fastest was 12.8. Right, so there's some interesting information, like the slowest shot for the expert is higher than the average of all shots for the novice, right? But we want to find out, are those observations, remember this is just a sample, are those observations purely due to chance, or is there actually a high probability that this is truly reflective of the population as a whole between novice and expert players. So in order to get that information, right, I do two tests. One's an F test and one's a T test. The F test determines whether the variance is the same. So you can see here there's a certain amount of variation within each shot, right? Not each shot is 8.5. You can see there's a lot of variation between that. And the same thing here for the expert players. It's not every shot being 10.9. Some are 9, some are 11, some are closer to the mid 12s, so on and so forth, right? So, in order to see if the variation between these two is at least similar or extremely different, do the expert players have much more consistent shooting and the novice people tend to be all over the place? Those are the kind of things that we want to determine, and whether or not that's just a chance observation or actually reflective of the population. We say is equal to f dot test, then open bracket. I'm just going to take these values, comma, and then these values. These are the ones that I'm comparing. Close bracket and press tab. And we get this p-value of 0.81. So our assumption is generally that there's no difference between novice and experts, right? We can state that as what we refer to as a null hypothesis, to in essence say we're trying to set out to prove that there is actually a difference between novice and expert players, but under the assumption that everyone's equal for now until proven different, right? That's how we want to kind of unpack it. So the F test is just looking at the variation, and it's saying the probability that the variation is the same is about 0.81 or 81%. So there's no real difference in terms of how much experts and novices vary between each shot, right? There's a certain amount of variability, and these variabilities are the same. So it's not that expert players tend to group their shots much closer together, and novice players are all over the place. They tend to be fairly similar in terms of that. I'm going to use that information, in other words, that the variation between these two is equal, to run the next test. Here RSA is equal to t dot test, open brackets. Again, I have to highlight the same two columns. Then it asks me to enter the tails. I can run a one-tail distribution or a two-tail distribution. In this instance, I don't know which one's going to be higher or lower, so I'm going to run a two-tail distribution, so I can double-click that. And then comma, the type of test that I want to run is the two-sample equal variance test. Remember, we said here that the variation, the chance that the variation is the same is quite high, so that's going to be an equal variance test, and that's what I'm going to do. The reason it's not paired is because the shots might not necessarily have been taken by the same players, so we'll run with that. Double click on that and then close brackets and press enter. And what you'll see here is the probability that these means are the same is incredibly small. It's less than 1%, right? So the fact that due to chance that we would observe the same kind of an average speed between novice and expert players by just taking that sample is less than 1%. So there can be we can be fairly confident that if we take a sample of novice players, that their average is going to be different to what the average of expert players is, right? And by quite a fair amount of certainty, right? The chances that we would get a same mean is, like I said, less than 1% out of all the samples that we take, which is kind of reassuring to know. So indeed, we would expect to see experts shooting at a higher speed than the novices. We'll just put this into a graph format. So I'm going to insert, just make sure that you click somewhere that's not close to your table. I'm going to insert a line graph, and I'm just going to chuck it over here. I'm going to right click on it, and I'm going to select data. I'm going to add a data column. I'm going to call this the novice values, and then I'm just going to highlight the mean for the novices. Press enter. Actually, what I want to do is I'm going to call this shooting speed, and then I'm going to highlight both the means. Okay, you'll see why I'm doing that in a second. Then I'm going to press OK. So in other words, it's taken the mean for one of the points and the mean for the other other point, but it's not labeled it correctly yet. I'm going to edit that. So I'm going to press edit, and I'm going to say label it under novice and expert, and you'll see that automatically updates there. And then press OK. Alright, not quite done yet. I'm going to still click on that line. I'm going to say add chart elements, go to error bars, more error bar options. I want it to have error bars on both end, and then I'm going to make it a custom value, specify the top error bar must be the standard deviation, and the negative error bar must be the standard deviation. So standard deviation above and below the mean, and then click OK, and you'll see that would have updated. I don't like lots of empty space, so what I'll do is you can see here that the bottom error bar is just above 6. So I'm going to double click on the y-axis. I'm going to go to options over here, axis options, and I'll say take that all the way to 6. Press enter, and then that takes away some of that empty space. I'm going to close that up. If you want to, you can edit this a little bit more just to neaten it up. I'm going to change the outlines to black, and then same thing here at the bottom, change those outlines to black, and that just to me neatens it up. I don't like the box on the outside over here, so I'm going to make that outline non-existent. And here we've got a graph that we can see over here that on average the shooting speed of novice players is lower than the shooting speed, but there's a certain amount of variation. You can see here visually now that the length of these bars, in terms of how much variation there was within each shot, is similar to how much variation there was in each shot for the expert players, right? It's not like this was really, really small, which means that each shot in the expert group was very, very similar, and here there was a lot more variability. You can see there that this will account for most of the shots that were conducted for novices and expert players. This is now what you would take and put into your document for the write-up component of the prac, and be sure to enter this information as well, right? Once you've done everything, so this whole table, these calculations and everything, you can in essence take all of this, press Ctrl C to copy it, right? If you're taking it into your prac sheet, just right click, paste it as a picture, and there it is, right? That shows me that you've done all the calculations, and then you do the write-up. That's it. Fairly straightforward.